Chapter 2, problem number 65. A penny is dropped from rest from the top of the Sears Tower in Chicago. Considering that the height of the building is 427 meters, and ignoring air resistance, find the speed with which the penny strikes the ground. Given information. Well, we know that it's accelerating, so G, the acceleration due to gravity, is equal to 10 meters per second squared, and I'm going to call down negative. The penny is released from rest, so the original velocity is equal to 0 meters per second. The displacement of the penny is given. It's directed down, so it's negative 427 meters. And they want us to find the final velocity. Now notice it says the speed at which it hits, but I'm going to find the final velocity, so I will include direction. Okay, so a diagram, VO, acceleration, VF, and displacement down. Now I'm going to use delta y instead of delta x since it's vertical. I'm going to change this. Okay. So I know G, VO, delta y, and I'm looking for the final velocity. Look at the equations, and you should find that the equation final velocity squared is equal to the original velocity squared plus 2 times the acceleration times the displacement is a good one to use to find the final velocity. So solving for final velocity, I get the negative of the square root of the original velocity squared plus 2 times the acceleration times the vertical displacement. I chose negative because it's obviously directed down, which is the negative direction. So substituting in the given information, we have 0 squared plus 2 times negative 10 times negative 427. Okay, that's meters. This unit is meters per second squared. Take the square root, you will get meters per second. And I get 92 meters per second. In the negative direction, which is down. I would now like to sketch the corresponding motion graphs. Well, the acceleration is down and it's negative, so I'm going to draw a straight line parallel to the t-axis. So this is G. On this graph, it starts from rest and it falls in the negative direction. So we have a straight line starting at 0 at an angle below the t-axis. And then here, it's being displaced downward, and it should be a parabolic curve because it's accelerating, and its slope should be increasing, but it should be a negative slope always. And there we go.